Okay, this is going to be the second video for rational graphs. What we want to do is we want to factor this, we've done a lot of factoring, so I'm going to sort of go through this so the video goes faster. That's going to be x minus 3, x plus 1 over x plus 1. Now what's going to happen is these go away, that's your whole, that's x equals negative 1. Okay, all right. So what you're going to do with that, okay, I'll have 1 over x minus 3, okay? So my vertical asymptote there is 3. My horizontal asymptote is y equals 0, okay, because that's the denominator power is bigger. So we go 1, 2, 3, okay, this, okay. So my domain is x is an element of all real numbers such that x can be 3 or negative 1, okay? My range is y is an element of all real numbers such that y can't be 0, okay? Our points of discontinuity are, I have an infinite discontinuity at x equals 3. I have a removable discontinuity at x equals negative 1, okay? All right. So my x-intercepts, all I got to do is do that one. So that's going to be y equals 1 over x minus 3. I'm going to put in 0 for y. And then what I would do is cross multiply that. So 0 equals 1. So that's going to be none for the x-intercept. For the y-intercept, I'm going to put 0 in for x. Okay, that's y equals 1 over negative 3, which is negative 0.3. Okay, so that would be here. All right. So obviously we see a curve on this one. All right. I want to build. I got this is 2, 3, 4. So which side do I need? I need that 4. Okay. So I'm going to put 4 in for x. 4 minus 3 is 1. So 4 comma 1. So 4 over 1 up. Now, since I have a hole in the graph, okay, a hole at negative 1. I want to just put a little open circle where that, that point is. Okay? All right. So on this one, what I would do is I would take out the 4. And then when I factor that, that's x minus 2, x minus 3. Okay? So I can cross off the x minus 3. So that's my whole at x equals 3, and then what I have is 4 over x minus 2. That's what's left over, okay? My vertical asymptote would be 2. My horizontal asymptote would be 0. Okay? My domain, x is an element of all real numbers such that x can't be 2 or 3. My range is y is an element of all real numbers such that y can't be 0. Okay, my points of discontinuity are I have a removable at x equals 3. I have an infinite at x equals 2. Okay, to find the x-intercept, I got y equals 4 over x minus 2. So I'm going to put 0 in for y. So if I cross multiply, that 0 equals 4, which would be none. For my y-intercept, I would put 0 in for x. So 4 over negative 2 is negative 2. Okay, so I got one here. Okay, now what I want to do, I want to look at this is 1, this is 2, this is 3. So I got to get the 3 side. Okay, so if I put 3 in there, all right, that's 4 over 3 minus 2. It's 4 over 1, which is 4. So 3 over 4 up. 1, 2, 3, 1, 2, 3, 4. Okay? Now, I would do this. Approaches the curve. Now, since the hole is at 3, I go back to that point right there, and I just put an open circle. So my y-intercept was negative 2. Okay? All right. This one, I'd factor to x plus 5, x minus 5. This one, I factored at x minus 2, x minus 5. So I would be crossing off that, so my hole is at 5. And so what I have is x plus 5 over x minus 2. Okay? So my vertical asymptote is x equals 2. I have the tie scenario, so 1 divided by 1 would be 1, okay? All right, so my points of discontinuity, I got an infinite at x equals 2. I have a removable at x equals 5, okay? I can graph these. My domain, x is an element of all real numbers such that x can't be 2, x can't be 5. My range is y is an element of all real numbers such that y can't be 1, okay? My x-intercept, what I'm going to do is I'm going to put 0 in for y. So I cross multiply that up, so that's 0 equals x plus 5, subtract 5. So x equals -5 would be the x-intercept, which would be right there. Okay, my y-intercept, I'm going to put 0 in for x. So that's going to be 5 over -2, which is -2.5. Okay, so that'd be here. So we clearly see there's going to be 1 in this area. Okay, now I got to build the other curve. So that's 2, 1, 3. Okay, all right, so what I want to do is put 3 in for x. So 3 plus 5 over 3 minus 2. That's 8 over 1, so that's going to be 8. So 3 over 1, 2, 3, 4, 5, 6, 7, 8. Somewhere in here, okay? All right, and so then I got this. Now, since I've got a hole at 5, 1, 2, 3, 4, 5, up here, put your little open circle. Okay, so you guys go ahead, give these a try. Okay, so what would happen here? I got 1 over x plus 4 and x minus 2, okay? All right, now nothing can eliminate here. So my vertical asymptote, I got 2 of them, -4 and I got 2. My horizontal, since this denominator power is bigger, that's going to be y equals 0. Okay, we'll get into the domain and range. So I just have an infinite at x equals -4 and x equals 2. Okay, all right. I have no holes. We'll get into the domain and range. These can be sort of special when you, especially the range, more or less. Okay, so my domain is still going to be all real numbers, except x can't be -4 and 2. The range depends on what the graph looks like, okay, for these ones with double. All right, so to find the x-intercept, the same concept, I would put 0 in here. Okay, cross multiply up, that would be 0 equals 1, which is none. Okay, so I got none for the x-intercept. Okay, all right. And then for the y-intercept, I put 0 in for y, 0 in for x, I'm sorry. 0 plus 4, 0 minus 2, so that's going to be y equals -1/8. Okay, so that's going to be here. Okay, now, the thing that's tricky with this is that you want to build, I've got, this is -4, this is 2. So I want to sort of see what this is doing, okay? So I got to put 3 in. So look, I got some numbers I got to put in. All right, I'm going to use my calculator for this, okay? All right, so what I'm going to do is I'm going to go ahead and put some numbers in to my function and see how they shape out. Okay, all right. So if I put -5 in, okay, because I got this. Okay, I put -5 in. I've got 1 divided by -5 plus 4, -5 minus 2. Okay, so I get a positive result there, which would be here, which means that this curve does this. Okay, I would do the same thing over here on this side with 3. I also get that positive, so that's going to be here. Okay, all right. And then I want to see where these go. So I'm going to put 1 on each side. So I got 1 and I got -3. So I'm just going to just put some values in here. Okay. Oh, come on. All right, that's -0.2. So that's going to be like here, okay? And then if I put, I'm sorry, that's here. Then if I put 1 in there, I also get -0.2. So here's what this does. This does this.